In this video, we're going to draw some force diagrams for situations where we have more than one object. So in this first example, block A is sitting on top of block B, which is sitting on the floor. Okay? Block A weighs 50 grams and block B weighs 100 grams. So the first question is, how does the force block A exerts on block B compared to the force that block B exerts on block A? Well, this is Newton's third law. Okay, so the forces are going to be equal in magnitude, but opposite in direction. And hopefully we'll see that when we draw our force diagrams. Since we have two objects, we're going to draw two force diagrams. So if we look at A has a force of gravity on it, and it has a normal force exerted by B. So we're going to look first at A, so I'll draw my little circle. All right, so A, there's a force of gravity, okay, on A by the Earth. So, and there's a normal force on A by B. So if we look at B, B has a force of gravity. It has a normal force in the upward direction by the floor and a downward normal force by A. So if we look at this, we got the force of gravity. All right, so I'll start with I'm going to draw that twice as big as I drew the force of gravity for A because it has twice the mass. So this is the force of gravity on B by the Earth. There's also a normal force, okay, on B by A. And since B isn't moving, this all has to be countered by a normal force on B by the floor. So what are some things here that are going to be equal? So in this picture, right, in this force diagram, those are congruent. Okay. We also said that the force of block A on B is going to be the same as the force of block B on A. So that's this force here, right? And then this force here. Okay, so the force of A on B is the same as the force of B on A in terms of being congruent. Okay? And then if we look at this here plus that, that would equal that. Okay, so that's our force diagram. We draw it for two different objects, and it kind of confirms Newton's third law for us. So let's look at another example. So I've got block B and block A. Again, block B is 100 grams, block A is 50 grams, and I'm going to exert some sort of a force to the right. And the blocks are both going to be moving together at a constant acceleration. All right? So since the acceleration is not equal to 0, yellow's not going to work. Acceleration is not equal to 0, the net force isn't going to be equal to 0. Okay, so hopefully we'll see that when we draw our force diagrams. So B has a force of gravity, right? And it has a normal force. A has a force of gravity and a normal force. Okay. Touching B is also this force, so there's a force acting in this direction and a normal force from A, and A has gravity, a normal force up, and also a normal force by B. So let's see if we can do those one at a time. All right, we'll start with B. So I've got my circle here. So I'm going to start with my force of gravity. Okay, so that's the force of gravity on B by the Earth. Okay, and then I'm going to have the normal force, right? The normal force on B by the floor. All right, and then we're going to have a force of A. Okay, so there's going to be a force, the normal force acting from A. So there's a normal force on B from block A. All right, and there's also going to be, I think I drew that a little big, so let me draw that a little smaller. Okay, There's also a force of friction here, okay, on B by the floor. Okay, and that's being countered in this direction. We've got the normal force here, okay, so the force normal on B by, say, the person. Okay, so lots of things happening there on B, right? I didn't draw in the friction there. And then for A, okay, so we're going to have gravity, right? I'm going to make that half as big as I did for B because it only has half the mass. So there's your force of gravity on A by the Earth. And there's your normal force, okay? Normal force on A by the floor. And then we've got a normal force here, right? On A by B. And this force and this force are equal in magnitude and opposite in direction, okay? And you can also include friction in here if you want to. But if you look, so we may have a little bit of friction here. So the force of friction on A from the floor. But your net force is going to be kind of this minus this. We're going to have a net force in that direction. So some things that are equal here, or congruent, right? Those two, these two, and then of course these equal and opposite forces according to Newton's third law. Okay? So the last one's kind of interesting. I've got two boxes, A's on top of B, and they're falling through the air. So they're falling, free fall at a constant acceleration, right? Our acceleration is going to be minus 9.8 meters per second squared. So our net force is not equal to 0. So how does the force block A exerts on block B compared to the force block B exerts on block A? Well, block A doesn't exert any force on B, and block B doesn't exert any force on A. So they're the same, they're just 0. B is falling away from A as fast as A is falling toward it. So they're not actually exerting a force on each other. So if you go to draw your force diagrams, they're going to be pretty simple. The only force on A is the force of gravity on A by the Earth. And the only force on B, right, is going to be the force of gravity on B by the Earth. So the net force on A is that, and the net force on B is that. So those are some examples where you have more than one object, and you'll get to practice some more on a worksheet.